Hey guys, in this video we're going to go over the parent functions. We are in Unit 2. Our essential question is what are the parent functions and how can knowing them be useful? Alright, so in Unit 2, this is the introduction to the three parent functions we use for the entire semester. In Algebra 1, we learn about three parent functions. We learn about the linear parent function, the quadratic parent function, and the exponential parent function. So what is a parent function to begin with? Well, a parent function is the most basic function. What that means is all other functions come from these parents. Just like how children come from parents, you have a starting parent and it makes children. So we're going to start with the most basic today. So the qualities and the aspects and all of the key features of all of the functions that you see today are going to be the most basic feature about them because they're the parent. And from those parents, you get the children. Now we're going to get to the children in later units because we haven't talked about that yet. So today's just the introduction to all of that. So the parent function is the most basic function. So that's why it's called the parent, because it starts there and then it can make a multitude of different functions, and there's an infinite amount. Okay, so the linear function. A linear function is a first-degree polynomial. Now remember back in Unit 1 when we talked about degrees, the degrees tells us the, spelled polynomial wrong. The degree tells us the highest exponent in our polynomial. So if I have a 7th degree polynomial, the highest exponent I have is a 7. If it's a 3rd degree polynomial, the highest exponent I have is a 3. Well, with a linear function, the highest exponent is a 1 because it's a first degree. So the biggest exponent you'll ever see with a linear function is a 1. Now it's important to note something here. The key word here is line in linear. So when I see linear, the key word I see is line. So this is going to be a straight line. Okay, so if I were to graph this, and anytime I see a graph of a linear function, it is always going to be a straight line. Now that line can be a diagonal line, it could be a horizontal line, it could be a straight up vertical line. So let's go ahead and draw some representations of how this could look. Well, you could have a line that looks like this, goes up and down diagonally. You could have a line that goes from the bottom to the top increasing. Now notice how I'm putting little arrows on the end. Now I'm putting little arrows on the end to state the fact that they go on infinitely. These lines actually go for an infinite amount, but instead of having to draw the line forever and ever and ever, I just put those arrows there and it's understood, hey, it goes on forever. You could also have a straight up and down vertical line or a horizontal line like this. So a linear function is a first degree polynomial and it is a straight line. Moving on to the quadratic function. Now, quadratic function is different. It's nothing you've probably really seen before, but a quadratic function is a second degree polynomial. And this one is not linear. So when I say it's not linear, it means it's not a line. It's actually a U-shaped. And we'll talk about what that U-shape is called in a second when we get there, but it is a U-shape. Now, you're going to have two types of quadratics you'll see in Algebra 1. So you'll see quadratics that look like a U, and if you're confused on how, remember, quadratic has a U in it, so you can think about quadratic making that U shape. All right, so quadratic functions are a U, and they either face up like this to make it look like a normal U, and remember we have arrows stating that those lines up there go on forever and ever. Or you could have a U that's upside down, like this. And again, those arrows would continue to go down forever and ever. So this is a U shape. All right, an exponential function. Now, it's neither a first degree or a second degree polynomial. It actually has a variable for the exponent. Okay, now the key word in this one is exponent. Okay, whoops. Okay, the key word here is exponent, which is why it's variable for the exponent. Typically when we see an exponent, we have a 2 or a 5, we have a number for our exponent. But here, our exponent's actually a variable. It's actually a variable. It's not even a number. Okay, and this is a curve. It's a curve shape. And I'll go ahead and draw some pictures of what this looks like. So, an exponential function has a variable for the exponent, and it's a curve shape. So it looks something like this. So it starts off flat and then it increases, kind of like a J, right? It's kind of like a J. Or it can also face the other way and go the other way like this. So they could be opposites of each other. So exponential functions kind of look like a curve where this one kind of starts off low and then it shoots up really high. This one starts off high and then it gets lower. So that's what exponential functions looks like. And you'll see when we're graphing these that you'll see that picture. Okay, so some vocabulary to go over. Now this is something that you guys have learned already, an x-intercept. Well, an x-intercept is where the function crosses the x-axis. Okay, so this is where the function crosses the x-axis. So again, let's go ahead and review graphs here, right? So if I have a graph like this, right, I have an x and y axis. It's going to be where it crosses the x-axis. So I'm going to go ahead and highlight the x-axis so we know, right? The x-axis goes horizontally. That's our xy. Now, another word for x-intercept that we learned in Algebra 1 is called 0. 0 means x-intercept. And I know that seems kind of weird because it's a number, but it actually does mean x-intercept. So sometimes on the STAR test or on one of our tests or quizzes, it'll say, hey, what's the 0? And what it's really asking for is what's the x-intercept. It's just not blatantly asking what the x-intercept is. It's asking in a weird way where it's asking you what the 0 is. So you want to make sure that you're fully aware that x-intercepts and zeros are the same thing because they're not always going to ask for x-intercept. They might ask for the 0, but it's the same thing. So don't get fooled. Okay, next we have the y-intercept. Now this is where the the function crosses the y-axis. Okay, so this is where the function crosses the y-axis. So I'm going to do the same thing I did earlier. I'm going to draw myself a little graph so I can show myself what the y-axis looks like, right? So I have my little x and y Cartesian plane here. That's called a Cartesian plane if you didn't know, this little funky thing here. Now the y-axis is going to go vertically up and down. So it would be, I would graph it and then I would see where it crosses the y-axis and it would be a point. Now, something to note here, an x-intercept, when we're talking about it, I'm going to go ahead and show you later what form it always takes shape in, and then a y-intercept as well. But probably for these notes, I won't do it, but eventually we're going to have to learn the pattern of what x and y-intercepts look like. All right, now these two new words down here are brand new to us. We don't know them. We have no idea what they are. So, again, brand new. Okay. Now, it's super important because we struggle with this concept a lot in Algebra 1, domain and range. Now, domain and range you're going to use for literally all of Algebra 1 forever. And you're going to use it in geometry, and you're going to use it in Algebra 2. So, it's important to understand this concept. So, I'm going to go ahead and start. Domain. Domain is always associated with the x value. Always. So, anytime it's asking you for domain, you need to be thinking x. Always thinking x. Which means, if it's asking you for the range, it's always talking about the y values. So, domain is going to be all possible x values. Now, when we get to the next lesson and then the lesson after that, actually, probably the next 3 lessons, all of those are going to have domain and range in them, and those are when it's going to become really much more important. For today, it's pretty much an introduction to it, so we're not going to be seeing it a ton. Okay, and then your range is going to be all your possible y values. Okay, so Unit 2 is really big on vocabulary, so you need to make sure that you're able to identify these things when it asks you for these vocabulary words, because we don't know all of these yet because some of these are brand new to us. Okay, so we're going to go ahead and start on the linear function. So, again, linear functions are our first parent function. We have 3, linear, quadratic, and exponential. So, the equation for the linear parent function is y equals x. Okay, now we want to be able to graph this. So we have a graph over here, but in order to graph something, we need a table. Now, I do have a separate video for graphing with a graphing calculator, but because our resources are limited right now, we're going to use Desmos. So I'm going to be graphing in this video using Desmos. So if you don't have Desmos, it might be a good idea to get it. So I'm going to use Desmos test mode, and I'm actually going to try to split screen this, so we'll see if this works. Oh, nope. I don't know. I'm trying. Try one more time before I give up, and then we'll just switch over to the app. Oh yeah, so it doesn't look like I can split screen Desmos. So when I open up Desmos test mode, I'm going to click the option of start practice test. So I'm going to hit start practice, turn on projector mode so that it's a little bit easier. So this is Desmos here. Now, I want to be able to graph this function. So I'm going to go ahead and type in y equals x. Now, when I type this in the calculator, I should get a line because remember, linear functions are lines. So I'm going to type in y equals x. Now, y and x are used a lot in algebra, so you're always going to find them over here pretty easily. So we're going to have y equals x. And you'll notice you get this awesome red line here. Now, it should be a line because it's the linear function, right? It's a linear thing. It should be a straight line. Now, if you notice, the more and more I zoom out and the numbers get bigger and bigger, this line goes on forever and ever. Now, I'm going to go ahead and show you how to get back to the main place, right? So if you hit this little home button over here, you can actually return back. So in case you get distracted in class and you decide to zoom out. All right, so this is where we are. Now, this is not allowed. You can't just draw a line for me. It does not work that way. You cannot just draw a line and be like, I'm done. That's it. It's not allowed. We need to be able to graph this, but in order to graph this, we need specific points. And I always ask you to give me 5 points, always. So this is how you get a table from a graph in Desmos. So once you've typed in y equals x, right, we've typed in y equals x, you're going to hit this little settings gear icon here. So you're going to hit that little gear icon. Again, you're going to hit this little gear, and it's going to pop up some options. Now you want the table, so you're going to select this table here, and it's going to pop up a table. And you'll notice there's actually 5 points on this line now. So the 5 points they gave you are the 5 points that are on this line. So I'm going to go ahead and I'm going to copy this table into my notes here. So I have -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Now, again, that's the same exact table that we have in Desmos. But what's weird about this? So what do you notice? Well, if you look at the x column and the y column, they're exactly the same as each other. Okay? They're exactly the same. Well, why is that? Well, your function says y equals x. So anything that x is, y is also going to be the same thing. So if x is 3, y is 3. If x is -5, y is -5. Okay. So now what we're going to do is we're going to plot these 5 points that we have. So I'm going to plot -2, -2 first. So -2, so you always go the x direction first, right? So it's x comma y, and you always go in the x direction first and then the y direction. Now remember, x direction is left and right, y direction is up and down. So I'm going to start with my first point, -2, -2. So I'm going to go left 2 and then down 2, and I'm going to plot a point. The next one I have is -1, -1, so I would go left 1, down 1. 0, 0, which would be at the origin. I would have +1, so right 1, up 1 for 1, 1. And then I have +2, +2, so I'm going to right 2, up 2. Now, here's something that they don't really tell you, and I'm going to tell you because it's harder to understand sometimes, but a line is actually an infinite amount of points connected to each other, okay? This just so happens to point out 5 points. Are these the only 5 points on this line? No, there's an infinite amount of points on this line, and I can show you. I can extend this table forever and ever. I can keep making it go and go and go. And notice as I extend my table, look what happens to the dots on my graph. Oops, that's not what I meant to do. Okay, look what happens to the dots. It keeps going on forever and ever and ever. So, there are more dots on this graph, more points on this graph, than just the 5 that they list for you. We just happen to only need 5 of them to graph. So, again, there's an infinite amount of points on this line. We just don't graph all of them. So, in order to state that there's an infinite amount of points, we want to make sure we draw a line to connect all these points together. Now again, there's more than just these 5 points on this graph. But I'm only graphing these 5. Oh, that's still a crooked line. I'm only graphing these 5 because I only need 5. Now, why do I draw arrows? Remember I stated that that line goes on forever and ever, and we want to make sure that we state that by putting those arrows, because it's not possible for us to draw a line that goes on forever because we'd run out of lead probably. So you're going to draw arrows there to state that you're going on forever and ever. And again, like I said, there's more than just these 5 points on this line. It's an infinite amount of points. There's actually points in between all of these points here. They're just not written. That's what a line is. A line is an infinite amount of points. Okay, so now we're going to go ahead and start by identifying our key features here. So the first thing it's asking us for is the x-intercept. Now remember, another word for x-intercept is 0, so make sure you keep that in your mind. Okay, now an x-intercept is where the graph crosses the x-axis. So I'm going to go ahead and highlight my x-axis so I can see this better. So where does it cross the x-axis? It crosses the x-axis at the point 0, 0. Now you must write this as an ordered pair. So it'd be the point 0, 0. Don't write 0, right? That's not a point, right? You need to give me an x value and a y value. You need to give me an ordered pair. Okay, next you're going to find the y-intercept. Now, the reason why I'm moving on is because there's only one x-intercept. It only crossed the x-axis one time, so I'm done, and I move on. Now, the y-intercept is where the function crosses the y-axis. So here's my y-axis in yellow. Where does this blue graph cross the y-yellow axis? Right, y-axis, that's yellow, sorry. Okay, it crosses there at 0, 0. Now you're like, why is everything 0, 0? Well, again, this is the parent function. It is the most basic function. So you're not going to see anything crazy, not any crazy numbers, nothing of the sort, right? When we move on to later functions, you'll see some more different numbers. But again, parent functions, pretty basic. There's not much about it. You're going to be seeing a lot of zeros today. Okay, now let's talk about domain. Now remember, domain is associated with your x values, okay? So domain is associated with the x values. So let me ask you, are these the only x values that are possible on this graph here? No, right? So x values go left to right. So hopefully you see that. The x-axis goes left to right. So here's my question. Does this line go on forever to the left? Yes. Does it go on forever to the right? Yes. It goes forever in both directions, right? It goes forever to the left and forever to the right. Okay, again, domain is your x values. So you have an infinite amount of x values because it can go on literally forever to the left and literally forever to the right, which is your x-axis, left and right. Okay, if it goes on forever both ways, how do we say in math an infinite amount of numbers or every possible number? Well, the way we say that in math is by saying all real numbers. Now, saying all real numbers every single time can be a hassle. So sometimes we could say ARN. So another way to say this is ARN for all real numbers. Now, on the STAR test, they're probably not going to use that. They're probably just going to say all real numbers, okay? But a mathematical symbol for all real numbers looks like this. So it's an R with an extra line inside of it. So that's the symbol for all real numbers. So again, why is my domain all real numbers? Well, domain is associated with my x values. If I look at my x-axis, which goes left to right, and I look at my blue graph goes on forever to the left and forever to the right. So it's infinite both ways. So I'm saying it's all possible, every single number, all real numbers. Okay, now we're going to move on to the range, which is our y values. Okay, now our y values, which include our y-axis here. So I'm going to look at my y-axis, right? Now, the question is, my y-axis goes up and down. Okay, I want to look at the graph as up and down. So the question is, does this blue graph go forever down? Will this graph continue to go down forever? Yes. Will this graph continue to go up forever? Yes, right? So it's going to go down forever, it's going to go up forever. It's an infinite amount of numbers both ways, up and down. So for my range, it is also all real numbers. Or also known as ARN, or the R with the fancy line in it. Now again, there are more than just these 5 y values on this graph, and I explained that because, again, this is an infinite amount of points. We only list 5 because that's all we really need. But range is your y values. Your y-axis goes up and down. So then you have to take a look at your graph, your blue line here, and see, does it go forever, both up and down? Yes. And then that's it. All right, we're going to move on to our second parent function, which is the quadratic function. Now, the quadratic parent function is y equals x squared. Now, I said in the very beginning that a quadratic function is u-shaped. And so I had you memorize, or had you try to remember it by looking at the u in quadratic here. Now, that u shape is actually called a parabola. That's just the name of the shape, so don't freak out. You're like, what is that? It's just the name of the u. We don't call it u-shape, we call it parabola. So I'm checking to see something real quick. So, again, the u shape is known as the parabola. All right, so now again, I need to graph this, but in order to graph this, I need a table. So I'm going to go ahead and type this into Desmos. So to clear out Desmos, you're going to hit those little X's to clear out everything that you have. Whoops. And I'm going to type in y equals x, and then the squared button is right here. Okay, so you're going to hit that button. Now, again, this should look U-shaped. It's a quadratic, so it's supposed to look like a U, also known as a parabola. Now, again, I need to graph this, so I need a table. So remember, to get the table, you're going to hit the little gear icon at the top, right? And then you're going to select the table. And then it's going to give you 5 points. And Desmos is always going to give you 5 points because Desmos is super nice. Now, if you look at your table here, we don't have the same values we did on the very first problem. Those values were different. These values are different. So, and that should make sense because they're two completely different graphs. So I'm going to go ahead and copy this table into my table in my notes. So I have -2, +4, -1, 1, 0, 0, 1, 1, 2, 4. So these are the values I get in my table. And I'm actually going to change this to purple because it's bothering me. Okay. All right, so we're going to go ahead and plot these points. Now, again, you can't just write a U because it looks like a U and you're done. That's not allowed, okay? You need to be able to plot these points. So, -2, +4. That means I'm going to go left 2, up 4. You always go in the X direction first. -1, +1. That's going to be left 1, up 1. Remember, negatives, you go left, and then positives, you go right for X. For Y values, positive is up, negative is down. Okay, you have 0, 0, so that's going to be at the origin. Okay, you have +1, +1, so it's going to be right 1, up 1, and then +2, +4. Now I want to draw a little U shape here to connect all these together, so I'm going to put a little graph that goes through all of these. Now, mine is not perfect, yours probably will not be either. Now, this actually goes on forever and ever. I can show you that in Desmos as well, right? If I zoom out on this, notice how this U, or parabola, goes on forever and ever. Hit the home button to go back. So, in order to say that it goes on forever, ever, you want to make sure you keep those arrows up there to state that. Okay, so next we're going to identify our x-intercept. Remember, an x-intercept is where your graph crosses the x-axis. So, where does this graph cross the x-axis? Well, it crosses the x-axis at the point 0, 0. Okay, so easy enough. I need to change this to green, actually. Okay, now, 0 is the next thing it's asking me for. Well, what's a 0? Remember, a 0 is an x-intercept. It's just another way to ask for the x-intercept. So if it's asking you for the x-intercept again, it should be the same thing, right? Also 0, 0. And again, these are the parent functions. Parent functions are basic. A lot of what you're going to see today is zeros and ones. You're not going to see anything too crazy. All right. Now you're going to be asked to find the y-intercept. The y-intercept is where your graph crosses the y-axis. Whoops. Okay, this is my y-axis here. Now, where does this graph cross the y-axis? It crosses the y-axis at the point 0, 0. And again, you want to make sure you're writing the points, right? You want to write an ordered pair. Don't give me 0 because that's not a point. Okay, I need to be able to locate that on a graph, so you need to give me an x coordinate and a y coordinate. All right, so for quadratic functions, you won't be asked to find domain and range just yet. We will get to that eventually in Unit 7. But for Unit 2, don't worry about it. You only need to know the domain and range for linear functions such as this. Okay, so then lastly, we're going to move on to our final parent function, which is the exponential function. So the exponential parent function is y equals 2 to the power of x. Now, like I said earlier in the very beginning, the key word here is exponent. And the reason why the keyword is exponent is because if you look at your exponent, it is not a number, it is a variable. So that's super important because it's not normal. It's completely different from what we're used to. So just like the previous problems, I need a graph. In order to get a graph, I need a table. So I'm going to use Desmos to help me. And again, if you're using a graphing calculator, you'll need to be watching the other video, not this video. Okay, so I'm going to clear that, and I'm going to do y equals 2, and I need to do the power of x, the exponent of an x. That button is going to be this one right here, the a to the b. If you look at it right there, I'm covering over it. It's going to bring you up to the exponent, and you want to type an x, okay? The x button is located here. So I'm going to do that one more time, right? Y equals 2 to the power of x. Okay, and this is just like I said earlier, it's going to be like a curve shape. Now, I want to be able to get some points from this graph, so I need to get the table. You're going to hit the little gear icon, and I hit the table option. Now you're going to have 5 points, and these points are different from the previous 2 graphs, which makes sense because they're not all the same graph, right? Like, they should be different. They're all 3 completely different graphs. So I'm going to go ahead and copy this table into my notes. So I have negative 2.25, negative 1.5, 0, 1, 1, 2, and then 2, 4. Just to double check. Yeah, okay. And just like the previous ones, it is not okay just to draw a sketch of this graph. You actually have to plot points, and I always need at least 5 here. So I'm going to go ahead and plot. So we're going to plot negative 2, comma 0.25. So negative 2 means I go left 2, and 0.25 means I go just a quarter of the way. So it's not even halfway through 1 yet. So it's going to be right here, 0.25, right? Because this is 1, so we're not to 1 yet. We're just a quarter of the way to 1. Okay, the next point I have is negative 1, comma 0.5. So it's going to be left 1 and then halfway up, 0.5. And then I have 0, 1, so it's going to start at 0, so I don't go anywhere left or right, and then I just go up 1 to 1 here. Then I have 1, 2, so it's going to be right 1, up 2, positive 2. And then I have positive 2, positive 4. It's going to be right 2, up 4. Now, before you draw your line, I want to draw your attention to something. So it kind of looks like over here that this line touches the x-axis. Well, I'm going to show you something. I'm going to zoom in here, and I want you to look. Does it actually touch my x-axis, which is right here? No, right? It's never going to touch my x-axis. So I can zoom over here and get really, really close in, and if you look, I'm going to keep going. It doesn't touch, and it looks like it does, but it doesn't. So when you're graphing this line, okay, it's okay, you can start up here, you're going to come down, but it's never going to touch the x-axis, okay? Now, you guys don't know what this is called yet, but there's an imaginary line here, and it's never going to touch. In this case, it's the x-axis. It's never going to touch the x-axis, so you don't want it to actually touch. Now, this graph goes infinitely both ways, so you need to make sure you have arrows on both ends of this graph because it does go on forever and ever. Okay, so we're going to go ahead and start by identifying our key features here. X-intercept. Well, the x-intercept is where my graph crosses the x-axis. But like I just said, this graph is never going to touch the x-axis. So if it never touches the x-axis, can it have an x-intercept? No. So if it doesn't have an x-intercept, you say none. I don't have any. Now remember, 0. It's asking you for 0. Remember, 0 is an x-intercept. You need to make sure you're familiar with yourself with that because you don't want to be caught off guard and be like, I don't know what a 0 is because I can't help you on a test and I can't help you on a STAR test. So if a 0 is an x-intercept, I know I have no x-intercept, so 0 is also none because I don't have any. Okay, so it's basically asking you the same thing twice. Next thing I'm asked to find is the y-intercept. That is where my graph crosses the y-axis. Well, if I look down my y-axis, it crosses my y-axis at a point. It crosses it right here at the point 0, 1. Now, let me ask you something. Is that different from the point 1, 0? That is yes, because where is 1, 0? 1, 0 is going to be to the right 1 and then up and down 0. So that point is right there. That is not on your y-axis, so it is super important how you order your numbers. So the point 0, 1 tells me that I would move 0 in x and y direction, so I wouldn't move anywhere left or right, but I would go up 1 to 0, 1. So you want to make sure you write actually ordered pairs for these. Don't just write 1, because that's not a point. I need an x variable and a y variable so I can locate it. All right, but those are your 3 parent functions. You have your linear parent function, which looks like a line. You have a quadratic parent function, looks like a U, which is also known as a parabola. And then you have your exponential function, which looks like a curve. So these are just the basic 3 functions. We'll talk about them way more in later units. Today's just an introduction to them. If you have any questions, please feel free to let me know.